Here we have two versions of the intelligent PBCT1 CTCSS Encoder Board, the PBCT1A, which is on the left, and the PBCT1B on the right. To give you an idea on their physical size and indeed how small they are, I'll just pan back and show you the relative size compared to a 2p piece. And what I'll do is I'll concentrate initially on the PBCT1B. Here we have a PBCT1B which I've connected to a power supply in order to demonstrate the operation of the unit. This particular board is set to default at 94.8 Hz, which corresponds to code F within the UK band plan. So when I power the unit up, it's going to give Morse letter F both visually and audibly to demonstrate that it's actually operating on that particular tone frequency. We now have two options. We can either press and release the PTT, which will lock that particular tone frequency into volatile memory, which means that should we do so, for the remaining time that the radio is actually powered up, it will always send 94.8 Hz as the subaudible tone frequency. But before we actually press the PTT, we have an option to change to a different tone frequency. So if we're mobile and we move to a different area, by simply pressing and releasing the button, we can select any tone available from A to S, and that's A through J, including tone S. I'll just demonstrate quickly. Okay, so we've gone through all the tones and back to A again. What we'd like to do now is keep that particular tone in its volatile memory, so what we would do is now press the PTT. So effectively any tone that you last selected before you press the PTT will be the tone that will be transmitted for as long as the radio is powered up. But for demonstration purposes, what I'd like to do now is unpower the unit and then repower so that you can see that it goes back from tone A back to tone F again. There we have it. Before I actually demonstrate the board working in an operational radio, I'd just like to very quickly show you the output waveform on an oscilloscope and also on a frequency counter so that you may see the actual tone frequencies. What I'm going to do now, just to demonstrate the waveform, is I'm going to first of all power the radio up. You're going to see on the scope display a small trace of the Morse code that's being sent for confirmation of tone, and then I'm going to simulate pressing the PTT by taking the appropriate PTT line high. Okay, I'm now taking the PTT high, and there we've got 94.8 Hz. As you can see from the time interval between peak to peak, we have 10.545 milliseconds. What I'd like to do now is just show you the accurate waveform on the fluke frequency counter. I'm now going to power up the board. This time it's connected to the multimeter, which is set on frequency counter mode, and when you hear the Morse, you'll see that the counter will register the Morse frequency first of all. Okay, so 1717 Hz. I'm now going to simulate PTT, and there you can see the 94.8. It takes just a fraction of a second or so for the counter to register, but as you can see on the scope, it's virtually instantaneous. When you apply PTT, the tone frequency is there. What I'd like to now demonstrate is the board working on different tone frequencies. So when I power it up and we get the default tone, which is tone F, of course. There we go. What I'd like to do is just change the tone frequency, this time to 67 Hz, which you'll hear as the character A. And now press the PTT. And there we've got 67 Hz. I'll do that again for tone B and tone C, just that you can see it's all operating as it should. Of course, what I've got to do is now simulate power down, so I'll switch it off, back on, select the tone, A, we'll go to B, and there we go. 71.8, 71.9. Switch it off again, go back to default F, and we'll select C. C being 77 Hz. And there we go. I won't do any more because you get the idea. I'd like to demonstrate the unit now, the PBCT1A, having been fitted to the Yaesu FT290 Mark 1. The tone is set to default 94.8 as per the demonstration board earlier on. Okay, so when I switch the radio on, we'll hear and see the Morse character F. Okay, what I've done in this instance is I've used the VFO button here on the front panel of the radio to act as tone select. So as before with the PBCT1B and its own push button, if I depress the VFO button and let go, you can see that it's scrolling through the tones. To select that particular tone, which is 77 Hz, which is tone C, I'll press and release the PTT. To demonstrate it working, what I'll do is just show you here. I've got this radio on squelch decode, okay, and at the moment the tone frequency of this is set to 94.8 Hz. Okay, so what we'll expect to see is a carrier present there on 144725, but no audio coming through because we're on the wrong tone frequency. G8WAL test. Okay, you could see the carrier there, but no audio. So what I'm going to do, just to confirm that the unit actually works, is power it down and then power back up to 94.8 Hz, default. G8WAL test. Okay, so you can see that the default is there, and as long as I keep pressing the PTT now, you can see that audio's constantly coming through. Now it's going to remain on 94.8 until, of course, we power the radio off and then change the selected tone frequency. So I'll do that now. I'm going to power off, power back on. That gives us now the option to be able to change the tone frequency. In this case, I'm going to select tone A, which is 67 Hz. I'll lock that into the volatile memory. Okay, so we're now on 67 Hz. There we go, no audio. In order to demonstrate that it is in fact working as explained, we'll change the tone frequency now on the receiver to 67 Hz. G8WAL test. Okay. Now, I did explain that earlier on, the board also has another feature, and that is that you can change the default tone frequency to any frequency you wish. Maybe you're going to be in a particular area that uses a different tone frequency from your own region for a number of hours, and it's going to be a bit of a pain to switch the radio off and switch it back on, only to have to reselect the tone frequencies. Okay, so in order to change the default tone frequency from F, we'll change it to A, just for demonstration purposes. What we'll do is we'll change the tone frequency as before by simply pressing the appropriate button you've decided to opt for as the tone select button before we press the PTT. Okay, so we're now on tone frequency A, 67 Hz. What we do, as before, is we lock the tone into non-volatile memory by pressing and releasing the PTT. But this time, I'll turn the audio down so we don't get feedback. But this time what we're going to do is we're now going to, instead of just using this as a temporary frequency, we're going to change the default. So, in order to do that, we simply press and hold the PTT, press and hold the tone button, the tone select button, release the PTT, and then release the tone select button. Okay. Now when we power the radio off and power back on, the default frequency will have changed to, as we've selected here, tone A. There we go. Again, once we power the radio up, we still have the ability to be able to change the tone frequency to whatever we want, but of course when we switch off and then back on again, we'll be back on tone A, which is the new default. I've now selected tone C, which is 77 Hz. I'm going to lock that into memory. G8WAL, turn the volume up there, and you can hear that we're not hearing any audio. So to demonstrate, I'll change the tone frequency here on the receiver to 77 Hz. G8WAL test. Okay, we now want to change the default tone as well to 77 Hz, but before I do that, I want to demonstrate that once you've pressed the PTT to lock the selector tone into non-volatile memory, the action of doing so prohibits you from any further change of the tone frequency. I'll switch off just to get back to the default tone A again. There we go. And you can see that the button's working until, of course, we select and lock that, and of course it then prevents us from changing the tone frequency further. Okay, so we're now on tone B. I'll set this to tone B default, and off and back on. There we go. So you can see how simple it is to operate. Similarly, with the old radio here, the Trio 2300, I've fitted a board in here as well, and that you could see was set to default tone F. It only gave the visual indication that time. I've enabled the radio in this particular instance to actually only give the tone when you open the squelch. So just to demonstrate. And I've used the tone button in this case on this particular radio just to select the tone frequency. So we can see it visually there, and we can hear it audibly if I open the squelch. Okay, so the next test, of course, will be to just test it through a repeater. Okay, I've now connected the antenna and taken the radio off the test set. So on power on, as you probably recall, we're now on tone B. Okay, so I'll just change the tone to tone F, which is the local area tone here. Okay, I'll lock that into the memory, and you can see we've instantly brought the repeater up. G8WAL testing access GB3WE. Okay, now what I'd like to do, obviously the default is set to tone B because of the previous demonstration. I'm going to reset it to tone F. I'll just move frequencies so that I don't open the repeater again. And press the PTT, press the tone button, release the PTT, release the tone button, power off the radio, power it back on. And there we have it, it's as simple as that. Just to show the flexibility of the PBCT1 A and B, I'd like to just quickly demonstrate one fitted to the FT290 Mark II. On power up, what I've done is I've connected the radio to the original OEM supplied connector for the CTCSS board. So now the board isn't in fact powered up by switching on the radio, it's actually controlled by the existing front panel controls. So in order to enable the activation of the CTCSS encoder, I need to press function and then tone on the radio, which will apply power to the board. Okay. What I've done here is I've used the call button, which used to be the 1750 Hz tone button, for the tone select. So again, we can scroll through all the tones, and by switching the unit off and then back on again, you can hear it'll go straight back to the default tone. G8WAL testing access, GB3BC. I wonder if anyone's listening who can give me a signal report, over.
Yeah, G8WAL, GW0PLN, P10 target. Yeah, almost fully quiet now. I've come to the end of my end. So, back to Paul from GW0PLN.
GW0PLN, G8WAL. Thank you ever so much for the report there, Peter. I'll change frequency and just try a few other repeaters, but thank you very much indeed. G8WAL.
Yeah, okay, Paul. I think we've spoken before, a long time ago, on WR maybe, or anyway, might be repeaters all that way anyway. Okay, so it's Paul. Speak again, GW0PLN.
Yeah, thanks once again, Peter. G8WAL, now clear. Here's just a small selection of the radios that have been fitted with the PBCT1A. I'll just demonstrate one radio in particular, the FT203. This vintage radio, the FT203, has also been fitted with PBCT1A, and in this case I've used the lamp button as the tone select, so repeated pressing will do the same job as the call button and the VFO button on the other radios. Similarly with the Pi Pocket Phone PF8, what I've done is I've used the squelch defeat button on this radio to show the tone frequencies, or select the tone frequencies rather. And here we go. And finally, I'll just show the PFX, which is again a PMR radio, and I've used the squelch defeat button in this case, and I've also drilled a little hole in the face here to show the tone. So there you can see the tone flashing rate, which is tone F, and if I just press the squelch defeat when powering it up, you'll be able to hear it as well. And finally, I've been asked by several amateurs whilst I've been developing this board, would it be possible to fit one in a microphone rather than the radio itself. This would be of particular interest to some people who've got multiple radios and a microphone that fits all. So what I've done is I've fitted one to a Yaesu YM24 speaker mic, which is used for the FT290, the 207 and the 708 range of handhelds. What I've done in this case is I've slightly modified the mic by the addition of a small hole for the LED, together with a push button that's just slightly proud of being flush. It works in exactly the same way as the board's fitted directly to the radio, but when I unplug the microphone and plug it in, or power the radio down and power it back up, you can see that the mic has defaulted now to tone F. I'll just use the push button to flip through the tones, so you can see it works in exactly the same way. Okay, I'll default it back to F by unplugging the mic and then plugging it back in. There we go, and I'll press the transmit button. I'm on the local repeater frequency, so I'll probably end up opening the repeater at the same time. There we go. Again, just to show that it works as the other demonstrations, I'll change frequency so that I don't annoy people on the repeater. And what I'll do is I'll change the default to A. So I unplug the mic, plug it back in. There we go. So I can now reselect tones. So there's A. So transmit to lock that in. And again, transmit, hold the button, release, release. And when I now switch the radio off and back on, there we go. There's tone A. Now this microphone does work satisfactorily through the repeater, but the advice of course is that whenever you fit a CTCSS board, you connect its tone output directly to the phase modulator input of the transmitter. The reason for that is that you're then bypassing any of the microphone preamplifier circuits, so that you're not going through any pre-emphasis that's provided by the mic amp stage in the transmitter. It basically means that you get a much better audio from the transmitter without having talk off problems as well. However, in practice, what I found with this particular radio and microphone configuration, it was quite satisfactory. There was no noticeable hum on the transmitted signal, but that might not be applicable to all radios, of course. So it is more desirable to actually fit the CT as recommended directly to the radio. So thank you very much indeed for watching.